Hey everyone, it's Chow here. Just a quick clarification for one of the topics. The neuromuscular junction, I mentioned it in one of my videos, and I also talked a little bit about the contraction cycle, but I didn't really go as in-depth in regards to sort of that connection between the neuromuscular junction and the contraction cycle, so I'm going to briefly discuss it in this particular video. So we have our neuromuscular junction situated over here. You have the influx of, in this case, acetylcholine into the cleft, and they bind to certain receptors. And what's going to happen is you have this action potential that's being sent to the axon terminal over here. And eventually, through the processes of the release of these neurotransmitters, in this case the acetylcholine, it's going to bind to the receptors are going to open, and you're going to have an influx of things like sodium into this membrane over here. And this influx actually causes a depolarization in the actual muscle tissue down here. And that influx, that depolarization, is then going to travel along this membrane over here, the surface membrane of the muscle cell, aka the sarcolemma, throughout the entirety of the surface of the muscle cell. Eventually, it's going to reach one of these things over here called the transverse tubules, also known as the T tubules, and they will actually, they're little tubes that go into the cell itself. And so the action potential is going to get propagated from the neuromuscular junction across the sarcolemma into the T tubule, and then eventually, as it passes through the T tubule, the depolarization, the action potential, is going to cause a release of calcium ions that's normally stored within this greenish mass over here called the sarcoplasmic reticulum, also known as the SR. So the SR has a high concentration of calcium ions, and it's going to release that calcium upon the passing of a depolarization. So depolarization causes a release, in this case, of calcium ions in the sarcoplasmic reticulum, which then is going to flow out, and that calcium then can go bind to the troponin, which then of course causes the shifting of the tropomyosin, which allows for the myosin cross bridge to then bind to the actin itself. So in this case, this is very fascinating because you have a situation of cross-bridge formation through the mediation of the neuromuscular junction, the influx of various ions, the passing of that action potential down into the T tubule, and then eventually the release of calcium ions. So as long as the action potential is continuing, then you have continued release of calcium, and that's going to bind to your complex and allow for the cross-bridging and muscle contraction to occur. Eventually, if the action potential stops, then what's going to happen is the sarcoplasmic reticulum is going to take back up those calcium ions. You're going to have a decrease of calcium out here, and that's going to ultimately decrease the amount of calcium binding, which of course shifts the tropomyosin and troponin complex back to the form that blocks and prevents the binding of the myosin to form that cross bridge. So this is actually what happens prior to the whole contraction cycle, and I just wanted to clarify it for the class. So thank you for watching, and good luck on the exam, and I will link the muscle contraction video in the description, or it's going to be placed within the playlist as well. So there you go. Thanks all.